Okay?
No, it's okay.
I
You can
know.
skip those.
Nah, I'm gonna. And sometimes a certain base works better than others. Alright, I'm going to jump to... Alright, yeah, sometimes there's a couple steps mixed in. Alright, Becca, follow me back over here. I tried to catch myself in the middle of saying "ruh," Becca, and I failed. Okay, here's a fairly simple one with a little more going on. 4 to the x minus 5 equals 3. Okay, I can't use logarithms yet from here. I can't plot the logarithms until the exponential piece is by itself.
Oh, plus 5.
So I'm going to add 5 to both sides.
Equals 8.
So it's 4 to the x equals 8. Be very careful here. There are some of you who, when you're in a hurry, will go, oh, x equals 2. Is that correct? No, because 4 to the second power is 16. Okay? I do know, however, that 4 to the first is 4, and 4 squared is 16, so I'm looking for a number between 1 and 2. From here, I can rearrange my logarithm, or I can take the log of both sides. Who has a preference?
Both sides.
Take the log of both sides, Laura said. She was the first one to articulate it. Laura, do you prefer log base 10 or natural log?
Base 10.
Okay. So I'm going to do log base 10 of 4 to the x equals log base 10 of 8. I'm going to whoosh down the x using the property of exponents with logarithms. And now I'm going to divide both sides by logarithms. Again,
it's 1.5.
And it's 1.5, I'm being told. Once again, remember, those properties of logarithms where division becomes subtraction, they only work if you have the log of 8 over 4. This is not the same thing as log base 10 of 8 divided by log base 10 of 4. Please don't confuse those. Okay? That's a little bit more complicated. Now there's a couple other tricks I have to show you. That's the same basic trick. There's be some fractions tonight. Don't freak out over them.
If we rewrote that as a log thing, it would be...
From here, if I just rewrote it straight up as a log, okay, what would it be?
Log base 4 of 8 equals x.
Log base 4 of 8 equals x. Yep. Okay. This asks the same question. 4 to what power equals 8? Good. And it's about 1.5. Good. Some of you, I think, are actually doing pretty well with this. Okay, here's a trick that bugs people a lot. I'm going to show you 2 tricks. One of them really bugs people. I actually think it's easier than what we just did. Some people think it's much harder. Okay.
It's not stapled.
Okay.
You're going to lose the page.
I'll try to be careful with it.
This is like so...
Good. I hope you feel the same way about this one. Becca, go ahead and follow me over here. I love this trick. I think it's easier. A lot of people don't.
Can I just do this one?
Yeah.
There's a couple ways to do it. Okay, 4 to the 3x equals 8 to the x plus 1. Okay, there's a simple way to do this that gives people headaches.
Hold on, I'm a little confused. So, why would just put the bigger number before, right? Because like log 4 is really first.
Is there a question in there, Jordan?
Yeah, what is it? You always put the big number first.
Okay, follow me back over here, Becca. Are you talking about from here to here?
No, down.
Here to here?
There to there. Because wouldn't it technically be like 4 over 8? Then you put 8 over 4.
It's not the, okay, big number not by size. The base of the exponent is the number that's always going to wind up on the bottom. And what it equals to is what's always going to wind up on top. Doesn't matter the size. If this were 8 to the x equals 4, I'd have log base 4 over log 8. Log 8, yeah, okay. It's not the size of the number that matters. Yes, Shade. Make do each trick on the test. Plan on it. Yeah, learn them all. Okay, Amanda, do you have a question on over here? Okay, let's go over here and let me show you this trick.
How did you learn them all? How many tricks are there?
2 or 3. Depends on how you picture it. Really 3. Okay, this is the second one. If you're given an equation like this, the first thing you need to check for is if these are both powers of the same number.
No, they're not.
Really?
Eh.
I'm sorry, the bases, the 4 and the 8. Can those both be expressed as powers of the same number?
2 and 3. Yeah.
2. These are both powers. 4 is 2 squared,
What?
which is then being raised to the 3x. And 8 is 2 cubed, which is then being raised to the x plus 1.
So you're saying the bases are the same?
Yeah, do the bases have a common...
Oh, and the base.
Can these base numbers be rewritten as exponents with a common base? Okay, in this case they can, because 4 is 2 squared and 8 is 2 cubed. Now when you're raising a power to a power, what can you do?
Is that a new example?
Multiply.
Multiply them. So this is 2 to the 6x
Oh, wait, there's no law.
equals 2 to the 3x plus 3. I have to multiply 3 by the x and by the 1. Take a moment and absorb that and ask me any questions on it, please.
I'm very confused.
Well, you just walked in, sweetie, so hang on a sec. We'll talk.
Another time.
Yeah. Catch up. Any questions on these steps?
No.
Okay, the
Yeah.
What is your very specific question, Amanda?
Oh, okay, you distributed it. Right.
Yes, I distributed it. Okay, now, here's an observation question. If 2 raised to 1 power equals 2 raised to another power, what do you think must be true about these powers?
Same.
They're the same. This is actually not meant to be a trick question. These are going to be equal to each other. That's only true if the bases are the same. I can't make this exponent equal to this exponent because 4 is not equal to 8. But once I change it so that 2 is the common base, these exponents must equal each other.
So no matter what, if the bases are the same, it's always equal to each other.
Yeah, these exponents.